Section 2 is about comparing two means. So this video, or this section, is going to be broken up into three parts. First, we'll be describing the shape, center, and variability of a sampling distribution of the difference between means, and then determining the conditions. The second video will be all about confidence intervals, and the last video about hypothesis testing. So let's look at the sampling distribution of a difference between two means. So we have the heights of 10-year-old girls, which is modeled by a normal distribution with a mean of 56.4 inches and a standard deviation of 2.7 inches. And the heights of 10-year-old boys that can be modeled by a normal distribution with a mean of 55.7 inches and standard deviation of 3.8 inches. Suppose we take an independent simple random sample of 12 girls and 8 boys of this age and measure their heights. So from that, we would know that the shape of each of them is normal because both population distributions are normal. The mean for the girls would be 56.4, the mean for the boys 55.7, and then for standard deviation, remember it is sigma divided by the square root of n. So for girls it would be 0.78 and for boys 1.34. Because both sample sizes are less than 10% of all girls and boys of that age in the United States. So let's look at the difference between the two means. So here's a simulated sampling distribution, the difference in sample means of girls minus the boys. So one set of samples gave that average was 56.09 for the girls and 54.68 for the boys. So when you subtract them, that's what that particular dot on the dot plot means. So what can we say about the difference in the sampling means? Well, the mean of the sampling distribution is equal to the subtraction of just their individual sampling distributions. And the standard deviation, remember we always add the variances. So we'd have 0.7. So again, this is a combination of chapter 6 and 7 combined now, where we talk about random variables and combining random variables, and then chapter 7 was about sampling distributions. So the resulting sampling distribution of the differences of means is normal if both population distributions are normal, or it's approximately normal if both sample sizes are large, meaning greater than 30, or if one population is normal and the other is large. Also, if you don't know the population distribution or the sample size is not large, then you can graph the data, and as long as there is not strong skewness or outliers, then we can say it's approximately normal. The mean of the sampling distribution is the difference of the two samples. And the standard deviation, again, is the sum of the variances, as long as the 10% condition is met for both samples. Do recall or remember that the 10% condition only must be checked when you're sampling, not when you're doing experiments. A fast food restaurant uses an automated filling machine to pour its soft drinks. The machine has different settings for small, medium, and large drink cups. According to the machine's manufacturer, when the large setting is chosen, the amount of liquid L dispensed by the machine follows a normal distribution with a mean of 27 ounces and a standard deviation of 0.8 ounces. When the medium setting is chosen, the amount of liquid M dispensed follows a normal distribution with mean of 17 ounces and standard deviation of 0.5 ounces. To test the manufacturer's claim, the restaurant manager measures the amount of liquid in each of 20 cups filled using the large setting and 25 cups filled using the medium setting. Let x bar sub L minus x bar sub M be the difference in the sample mean amount of liquid under the two settings. So what is the shape? What is the mean? And then calculate and interpret the standard deviation. So the shape, it's normal because both population distributions are normal. The mean is simply 27 minus 17, which gives us 10 ounces. And the standard deviation, we'll add their variances and then of course have to take the square root. So we get 0.205 ounces. Again, here we do not have to check a 10% condition because we're not sampling without replacement. Remember, 10% is all about when we're sampling. And to interpret the standard deviation, it means that the difference, we did large cup minus medium cup, and the sample mean amounts of liquid typically varies by about 0.2 ounces from the true difference in means of 10 ounces.